everyone, and welcome to today's episode. I am joined today by Dr. Woody Lane, a livestock nutritionist and forage specialist and consultant, who's the owner of Lane Livestock Services. He's also the author of 3 books on forages, grazing, soils, and livestock nutrition. And he's a former state extension specialist at the University of Wisconsin. And we are going to be talking about something that never gets enough attention, whether you're raising goats or any other kind of livestock, and that is pasture. Welcome to the show today, Dr. Lane.
Well, thank you, Deborah. It's a pleasure to be here. Thank you for asking me to be on.
I love your book, Capturing Sunlight, and I noticed section 1 has a subhead, which I think is just fabulous. It's the marvel of the rumen, which, if people don't know what the rumen is, I just think it's the coolest thing ever. Can you tell us, what does that mean, really?
Well, the rumen is, we have arms and legs, and animals have legs and heads and stuff, and a rumen is an organ. And people are kind of familiar with the fact that goats or cattle or sheep have what they call 4 stomachs, one of which is the classic stomach that we have, the same thing. It's very acidic and et cetera, et cetera. But in animals like goats, over time, they evolved so that that particular organ split into 4 different parts. And one part, well, without going, one of the parts is much larger than the others, and that's the rumen. So it's actually part of the entire stomach. That's like upstream, if you will. If you think of the gastrointestinal tract as a long tube, the stomach is right there in the tube, but then downstream from the stomach is the small intestine, which is the intestines. But upstream, that's where these other parts are, and the rumen is a large part of that. And basically, what the rumen does is, before feed gets into the stomach and the small intestine, it sits inside the rumen and rots, ferments. It's another way of saying rots. It ferments without oxygen, the same way what happens in a septic tank, except it's more complex and it's differently complex. But basically, it's a big house for microbes. And in today's world, there's a huge interest in the microbiome in humans. You read about that all the time. Well, the microbiome is the large intestines at the end of the tube. Well, what's going on in the large intestine in humans goes on in a much greater sense when it happens in the rumen in an animal. And what that is primarily designed to do is to digest fiber, because we can't digest fiber. Animals, humans, dogs, cats, even cattle, sheep, do not excrete the enzyme to digest fiber. And fiber means cellulose and its cousin hemicellulose. And these are very long, large molecules. And you need a certain enzyme to break them up, called cellulase or hemicellulase. And we don't create that. However, rumen bugs, bacteria do. And so effectively, the rumen is a large house of fermentation sac for all these microbes. And when fiber goes into it, hay, silage, grass, whatever, they specialize in breaking down this fiber and extracting nutrients from it that the animal can absorb and therefore get nutrition. So effectively, the rumen is a very highly specialized organ for extracting nutrition from fiber. We have a smaller part of that, as we all talk about eating fiber. Well, we don't have the enzymes to break it down, but it goes down into large intestine, and some of it's broken down there. And, we absorb stuff, and there's a lot of research going on about that, and that's called the microbiome. The rumen is a much larger part of that for those types of animals that have rumens. And you know what the biggest ruminant is? Well, before we get to that, animals, to ruminate means to chew cud. Mm-hmm. A ruminant is an animal that chews cud. So therefore, what that does is part of the stuff that's in the rumen comes up, gets more chew, goes back down. That's a very important part because it adds a lot of saliva to it and buffers the rumen's pH and all that type of stuff that goes on. But it has to go up and down the throat, the esophagus. All right. Well, now I'll come back to the question. What's the largest ruminant?
Is it the giraffe?
Yes.
Oh, I got it right.
Just think about that for a moment.
Yeah, that's a long esophagus.
Yeah, really. And it wouldn't be really cool for the giraffe to put its head down just to do that, because not in lion country, you don't. So and that is an intriguing concept. But it's the same concept, though. Sheep, cattle, goats, deer, elephants are not ruminants. because their fermentation sac is at the other end. It's like the microbiome. It's a huge large intestine, like a horse has a huge large intestine. So ruminants are animals that can chew their cud. And you might think, well, what about animals like llamas and alpacas? Well, there's a specialized, they're not ruminants per se. They're not listed, biologically as a ruminant. They're called tylopods, which is, South American camelids. But they have a rumen. Instead of a 4-compartment stomach, they have 3 compartments. So, but they do exactly the same type of thing. So our rumen is a very specialized organ. It also can do things because its microbial population can take some things that are not protein, like urea, or just some waste, various types of nitrogen compounds, and convert them into protein. So that's why we can feed a protein block to animals, because that'll have molasses and urea in it. And a goat, for example, can convert that into protein and then absorb the protein. And, just like they had, a steak or something. And also a rumen acts as a kind of a barrier to some toxins. There's a lot of toxins in this biological world of plants. And the bacteria and protozoa in the rumen sometimes, not always, but sometimes can break those down so that detoxify the things before it gets down into the stomach and small intestine. Whereas a horse, for example, is very liable, for example, mold in moldy hay. It's classic. It's one reason that red clover is not liked compared to other types of forages for hay for horses, because horses are particularly susceptible to mold toxins, mainly because it goes into the feed, goes into the mouth, goes down to the gullet, right into the stomach and small intestine, and they get full blast of what's in there. Whereas a goat, it goes into the rumen first, and then things change, and then by the time it gets down to the stomach and small intestine, some of these toxins are detoxified. So it's safety. So the rumen is an amazing organ. In addition, goats, cattle, sheep also have a large intestine. So basically, there's 2 parts to its gastrointestinal tract that are designed for fiber. So these animals, like goats, are exquisitely designed to extract nutrients from fibrous feeds. And fibrous meaning grass, leaves, trees, whatever, whereas we can't. So they can do something that we can't. And then, of course, we can get the products from the goats.
That is so cool. I always love that explanation. It's not nutritious to us, but it's nutritious to them, and their body is able to digest it and get valuable nutrition from it. So the first real question I want to ask you is one that I know you've heard many times. I've heard it many times, and people always think this is such a simple question, and they're expecting a really short answer, like maybe even just, 3 or 4 words. And we both know this is like probably the simplest question in the world with the most complex answer. So I'm not actually asking you to answer this question, but to explain why this is such a challenging question to answer. And that is, how many goats can people have per acre?
It's actually a simple question.
Yeah.
But our system has been designed in the United States to make it complex. Is that a good answer?
Keep going.
Well, all right. If you, and I've heard this here and other places, of course, if you go and get anything, the Extension Service, NRCS, or whatever else, a recommendation on how to graze, what does it say? You put the animals out when the grass is about 9 inches and take them off about 3 or 4 inches, right? Or some combination of that. Maybe it depends on the species. Maybe it's perennial ryegrass. You might put them out at 7 inches, take them off at 2 inches, etc. Tall fescue would be different, and alfalfa is different again, but they'll say, go out and how many inches to do this, take them off at certain inches, right? That's what you read and hear. And my question as a nutritionist is, how many inches does a goat need to fulfill its nutrient requirements for a day? Let's take a lactating doe in early lactation, say 2 months after she kidded. How many inches of grass does she need to meet her nutrient requirements? Well, I've asked that question in many, many workshops. And the answer is always the same. I get this deer in the headlight look, because if you can't answer that question, you can't say, I've got 5 acres, 30 goats. How long can they stay out there? You can't answer that question. Or I've got 12 goats. How many acres do I need to keep them out there for a week? Very different ways of phrasing the question you asked. Well, the reason it's a problem in the US, if you have to balance a diet for a goat, first thing you do is you have to say, how much do they eat? And then in that package, put as much protein and energy that they need to fulfill their requirements, because the requirements are listed in tables, and the package that they eat is their daily intake in pounds. So our recommendations and the way we work at it is in the amount of stuff in pounds. Yet the agronomic recommendations are in inches. That's why things are complex, because you don't have the tools to combine them. There are tools, we just don't use them in the United States. That gives you an introduction to that answer. And when I teach courses in workshops and courses in pasture management, that's the opening for what is ultimately an entire course, but certainly at least 1 or 2 3-hour sessions of classes on how to make this thing work. But I can explain it pretty quickly in a general sense. And it's in my books. It's in a lot of detail in book 1 in how to do that. But effectively, what you end up doing is you actually measure how much stuff is out there on a pasture. Instead of inches, how much feed is out there in pounds? All of a sudden, if you know how many pounds are out there and you know how many pounds an animal eats per day, and multiply that by the number of animals, you can have an estimate of how much it takes per day to feed those animals. Instead of inches, I don't care about inches, except a little bit. We now know a lot more about parasites, so we want to leave a certain amount. But that's part of it too, because how we look at it is this. We see how much is out there, total, and we call it mass. Mass and amounts are the same thing. It's that your mass is 130 pounds. That's how much you weigh. Your mass is the physics class way of saying how much stuff there is. So the total amount out there, total amount of pounds is total. That's everything out there right to the ground. When you're grazing, you're not going to do that unless you're going to renovate the pasture and you just want to do that. But normally you're going to leave some. Well, what you leave is called the residual. How much do you leave when those animals leave the pasture? How much are you going to leave there? When you're making hay, it's very, very little. When you undergraze, it's a lot, whatever. But you got to leave some. You're not going to scalp things. So you got the total mass, and then you got the residual mass. And the stuff in between is what's available for food, for feed. That's called the available mass. And when you calculate the available mass, then you can go back and say, okay, here's my animals. Let's say they need 100 pounds a day. This is dry matter. They need 100 pounds a day to fulfill their herd's requirements for the day. And I've got 1,000 pounds out there. So therefore, I got 10 days of feed. If I keep them out there for 30 days, I'm going to scalp the ground. And I know this before I open the gate. So if we work in terms of mass, of the amounts that's out there in the pasture, then we can relate that to how much the animals eat. And it doesn't have to be in 3 decimal places. You're taking guesses. And not only taking guesses, but when you do that, you change the size of the pastures by electric fence. Mm-hmm. So if you have a pasture that says, oh, that's much too big, so you can bring the fence in to make it smaller, which gives fewer days, but that's maybe what you want. You have all that flexibility based on how much is out there, where you can't make those judgments, at least intelligently, if you're talking inches. And that's the way they do it in New Zealand and Australia, England, France, Brazil. Use a calculator. And the thing is, once you can become good, once you do it a bunch of times, your eyes are pretty good at making judgments. I mean, when you look at a doe, and you are estimating her body condition score, how do you do it? You put your hand on her, right? And you use visual. What you're really measuring is how much subcutaneous fat she's got. But you're not taking a measurement of subcutaneous fat. What you're doing is you're using your hand and making an estimate. And after a while, you get pretty good at it. What you're doing is you're calibrating your hand. Or in cattle, you don't put your hands on cattle. You look at them, but you don't really want to put your hands on cattle. But you look at them, and in their scoring system of 1 to 9, okay, and you can say, oh, that's a 4.5, that's a 4 or a 5 or a 7. What you have to end up doing is calibrating your eye in cattle and your hand in goats or sheep. Well, when you make enough measurements, you learn how to do this with your eyes on a pasture. And you can look at that pasture and go, well, it's 2,500 pounds of dry matter out there per acre. And if you're off, when you move the fence and you're off, you'll get feedback right away because there's too much left. Or I had to move it faster because then I was wrong. And you're training your eye. And the way we do that in our classes and in our forage groups and stuff is we take a square, make a square, a foot by a foot. Actually, it's a foot by 11.5 inches because then the calculations just add 2 zeros. But and that's in my book of how to do that. You take a square, you can build it fancy, or you could take a cardboard box, flatten it out and cut out a square. It's really, I use that for years. It's very simple. You cut out a square of 12 inches by 11 and a half. And then you take that square, put it down on the ground and cut everything to the ground with a shears, and make sure they're good shears, that they actually work well. Otherwise you get very upset. And you take it to the ground, and then you dry it in a microwave. You take off the tear of the bag, use it in a paper bag, not plastic, but a paper bag, put the stuff in there and dry it down so that the weights, and you're measuring the weights on a postal scale in grams. And so you measure it until the weights stop moving. The weights go lower and lower as you dry it out. And then finally you stop and then take off the tear of the weight of the bag. And that's how much grams of forage there were out there per square foot. And then if you do it by 12 inches by 11 and a half, let's say you get 21 grams of forage out there, not including the bag. It's 21 grams of dry matter. And if you have this little square out of a 12 inches by 11 and a half, all you have to do is multiply it by 100. And that's how many pounds of dry matter per acre. It was that straightforward. So if I have 21 grams out of that microwave stuff, then I've got 2,100 pounds of dry matter per acre. The one hint, though, is make sure that you tell everyone in the house that you're going to do that, because the smell is pretty intense. And don't do it the day before Thanksgiving. So, and that gives a number, and that number tells you how much feed is out there. Then you make your judgment, go, I'm going to leave 1,000 pounds. So say I start out with 2,500 pounds of dry matter out there. I'm going to leave my residual of 1,000 pounds, which means I've got 1,500 pounds of dry matter above the residual. That's the feed I've got. That's how much that's going to be grazed in that acre. And then I can figure out, I guess, X number of animals and do a little calculation. It's not hard. Initially, it seems very confusing. You do it once or twice, and it makes all the sense in the world. And it's in my book. I have the last 25 pages of that book is written as a textbook, because it was written as a chapter in the ASI handbook. And I have the copyright of it, so I can use it for my own book. And it explains in a textbooky type way how to do things. The rest of my books are these different essays, and they tell about the same thing in different ways. But in the last 25 pages of my book, it just lays it out. I mean, bang, 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 just like a textbook. So that's the reason why it seems so complicated when you ask that question, because you're trying to relate how many inches of stuff to how many pounds the animals need or will eat. And you can't do that. So that's a long-winded answer to what seems to be a simple question. But when we get the tools to do it, it's very straightforward.
Right. And I think what you've just illustrated is why that answer is going to vary from one farm to another farm.
Sure.
So
Absolutely.
that's why there's not one single answer, because every farm has different forages, different conditions, different animals, different everything. So,
And it's absolutely right. And in different times of the year. Say, for example, you got pastures and it's early May. Then you come back to it in mid-August. They're not going to be the same stuff. Firstly, the different stuff might be growing, and certainly at different speeds. And it depends on which way the pasture is facing. It's facing south, where it heats up more. Is it facing north? Is it a little bit shady? Is it well drained, or is it not well drained? It's got heavy soil, so therefore it retains this heat for longer. I mean, it's a cooler soil because it's wet. I mean, and then different species will grow differently, depends on the time of the year. Well, that's fine, of course. So what you do is you take the measurement different times a year. And the idea is you take measurements like that and you train your eye. So you can walk out there and go, oh, there's about 1,000 pounds and there's not enough stuff out there for feed. No, I better not. I better put them in somewhere else, or get it on the neighbor's land or something like that. And you could do that. And the idea is, what we do is we would take this square, put it down, dry it down as an exercise, and then go, okay, here we have a number. Let's say it's 2,500 pounds an acre. But everybody has seen that square, maybe taken some pictures of it before we cut it. Now we know what 2,500 pounds looks like. Now we're training our eye. We're not being graduate students where we take 30 of these little squares and take an average. No, that's for research. What we need to do is be able to train our eyes so that we can look at a pasture in a straightforward way, take a reasonable estimate of how much is out there, and equate that to how much the animals need per day, and take an estimate, and then calculate how many days. And you can do that before you open the gate.
yeah, that is awesome. That is way more detailed and like the best answer I have ever heard anybody give to that question. So
Thank you.
I can see why people love your books so much, because this is so practical and so useful. One of the biggest things I see with people doing rotational grazing is that they think that they need a lot more land than they really do, and that they try to put like a small number of animals in an area that's really way too big. Can you talk a little bit about that and the
Yeah.
importance of moving them more quickly?
Yeah. Move them quickly. End of question. No. Actually, it opens up a very, very important part. There are I think there are four basic rules to good grazing. Number one, well, you have to realize how forages grow. All right. And without a whiteboard, or when I teach in classes or workshops, I love to use a whiteboard because I can draw things. I'm the poorest drawer in the world, so people make fun of it, but I still can draw a line. And imagine how forages grow with the x-axis being time. So, as you see it, and then the y-axis is being how much is out there. And what happens is forages grow not in a straight line, but in an S curve. Initially, they don't grow very fast because they got only a couple of little leaves in there. And then as they get more and more leaves, they grow faster and faster. So the curve starts out kind of slow, and then it picks up speed, like goes really fast per day. And then it gets to a certain point and it starts to even out at the top. And you have basically a large S. That's how they grow over time. Well, that S is in three parts. The first part's that low part. The second part is this very steep part where it's every day it's putting on a lot. And the third part is the top part where it's still going up, but going up very slowly. It's an S. And those parts are called phases, phase 1, 2, and 3. Phase 1 is that slow start part. Phase 2 is this fast stuff that goes on every day. I mean, fast. Every day it's adding a lot. And then phase 3, it's starting to mature and slowing down. It's still adding more stuff, but per day, it's not very much. The thing about it is phase 1, phase 2, phase 3 is absolutely critical because that's what's called the forage growth curve. And that brings us back to grazing. When do you put the animals in and when do you take them out? And the best grazing, you put them in at the top of phase 2. Before that, the curve starts to flatten out. You put them in phase 2, at the top of it, ideally, and you leave them in there until they're at the bottom of phase 2, because you don't want to get into phase 1 because that's a slow recovery period. If you get into phase 1, because you're going to come back on that piece of property, well, you want to come back when there's enough forage there. But if you go into phase 1 on that previous way through, it's going to take an extra 2 weeks to get up there, or 10 days. So over the course of every time you cycle, it's taking an extra 10 days to get up to where you want to graze. Well, 3 times through the cycle, you've lost a month of grazing. So that brings us to the principles. One of the main principles is stay in phase 2 growth. That's your most efficient. It's highly nutritious. We don't have to worry about nutrition when you're in phase 2 growth. The nutrition goes down when you get it more mature. That's number one. Number two, leave enough residual at the base. Don't go into phase 1. And that also means you don't go down towards the ground. You leave a few inches. So that's the second one. Leave enough residual. Protect that residual. The third one is protect the regrowth, which is the residual. Because what regrowth is when you graze a plant. Have you ever mowed a lawn and then watched the grass and saw how fast it was growing?
Oh yeah.
Kind of like watching paint dry, right? But okay, when you mow a lawn or you graze, how many days does it take before you start to see new green shoots out of those plants?
It seems really quick, like just within a
That's
few
right.
days. Yeah.
That's exactly right. I mean, we see it in 5 or 6 days, 4 or 5
Yeah.
days. Depends on the type of plant. It depends on the grasses, and it depends on the moisture, of course. And I mean, it depends on the time of year. But I'd say 5 days. All right. If you have animals on that place right there in that little paddock or whatever, and they've grazed it and they're still there after 5 days, and they're walking around, they got nothing else to do except look for food, right? What are they going to eat first?
The soft, sweet, tender
That's
stuff
right.
that is sprouting.
Which is your regrowth,
Yeah.
which is exactly the type of plants you want to keep in that field, usually, because they're the ones coming back fast. And yet you're putting selective pressure against them by grazing that regrowth. So one of the third principle of good grazing is protect the regrowth, which brings us to another main principle is get your animals off the field within 5 days. If you have animals on that field or pasture, whatever that is, more than 5-6 days, then those animals are going to be eating regrowth. That has a major implications because there are all sorts of grazing strategies. You put the kids out before the does, or or you put does and then cattle and you multi-species grazing, whatever else, and you do this, or maybe you put turkeys out there. I don't care. You name it whatever you want, and that's an academic thing, and they're very good strategies, however you do it. I want to protect the regrowth. I want animals off that little piece of property in 5 days. It doesn't have to be half a day, but the maximum is 5 or 6 days. Mm-hmm. I can put different species. They're all off it in 5 or 6 days. Now, let's say a dairy farm, for example, moves animals twice a day anyway. So their breaks might only be half a day's worth. Okay, that's natural for that type of, but if someone's grazing goats, and they're not moving them every 12 hours, they're moving them, they have meat goats, for example. Well, put them out there for 4 or 5 days. That's fine. And how much they put out there depends on how much is out there. You made the calculations. But whatever it is, you don't want it more than 5 days. So that's a basic rule. I call it the 5-day rule. So those are some basic rules of good grazing, and they're relatively easy to apply. Oh, one other one that makes good sense for grazing is the minerals and water stay with the animals. So when they move, a little mineral feeder or water, hoses are your best friend. You can have 200 feet of hoses out there without any problem at all. Just have risers somewhere and have clean water coming to them. And you could use I've seen, you get a plastic or rubberized water place to feed, and you can use a Hudson valve in there that'll automatically stop the water from coming in with a hose. You can build that thing very easily. I can't build anything, and I was able to make it work. So you put a Hudson valve in a water truck. We're not talking big water truck. This is a small rubberized thing. You could put 100 goats out there without any problem at all, and have that, and you can move it around. It's very easy to move it around. Pick it up and walk over, 100 yards, whatever. So there's ways of doing it. Mm-hmm. But if you have the goats always go back to the barn, unless there's predators or something, they go back to the barn. What that means is they're also eating on the way back and forth, and they're putting pressure against those paddocks or against those forages. So by being able to keep the minerals and the water with the goats, then you have this unit that's moving under your control around your farm, and you're always protecting the forage. Because kind of what it amounts to is that, yeah, you're a goat farmer, you're raising goats, but you're also a grass farmer, and the goats are your harvesting units. And you might love them and you name them and whatever else. That's great that you've written in your books about caring for them, etc. But as I say, you're capturing sunlight in this grass, and grass being the large term for all forages. And in goats, it could be, large, more than grass. It could be browse, but you're always protecting that because that's what you're really growing. So that gives kind of a long-winded answer to your question about how to graze.
Oh, I love that. That's really good, because my suggestion has always been there's probably going to be some trial and error in the beginning. Look at what you think they can eat in 5 days, set up your fencing, and then, if they haven't eaten it in 5 days, you probably should move them, and move them to a smaller area next time.
Right, exactly right.
But I love the fact that you gave people some good math that they can do. They can actually make some measurements and stuff to get a better idea of what to do, like you said, before they even open the gate.
And it's kind of really important to recognize what you're doing when you're moving the fences. You're allocating feed. That's what you're doing. You're not saying, well, here's my, big operations in Oklahoma and Texas, we're going to have permanent paddocks, of course. But they're doing the same thing in their own way with cattle, and they're moving different paddocks. It's a larger scale. Principles are still the same. But with the people raising goats and what they're normally doing, you have electric fence. You can set it 10 yards further out or not, and you could quickly get feedback going, uh-oh, I left too much there this time, and next time move it a little closer. And the goats are training you really well. All right. And the other thing is, it's kind of like a basketball game. You can learn the basics of dribbling and shooting and all your plays and whatever else. Okay. You learn that. That's what they do when they do their other practices. but you actually get in a game. You're using those principles, but everything is flexible because things are changing. And every year is going to be different because the weather is different. And then it's built on the previous years, how good or badly you handled the forage. So, you got more weeds or less weeds, and whatever else. You got, all this type of thing. You may have more animals or less animals. So, but the principles stay the same. And you've heard of the term management intensive grazing, and as opposed to, it's different than rotational grazing. Rotational grazing, you've got this setup. You go, I'm going to pay X number of days in each cell, and I'm going to come back in 32 days or whatever else, or 16 days. That makes, actually, people who do that, it falls apart. It's a lot of extra work, and you don't get a lot of you doing it that way. You don't get a lot of increase because of a lot of extra work. And the reason you don't is because it's too structured. Plants don't grow according to structure. They grow according to what time of year it is. I mean, a wait period of 30 days before you get to a place may work really well in August, would be a disaster in May. So what you have to do is move fence according to how the plants are growing. What happens if you fertilize a place? Suddenly you get 3 times the amount of growth. Now what? Or just part of what you fertilized. So you get to that part, you're going to move the fence a lot faster. That's okay. What you do is you allocate feed according to the principles, and you move things around. And the management intensive grazing, it's not the classic rotational grazing, which you could put on a blackboard or whiteboard and have these little boxes and say every 10 days you do this or that. No. What you do is you move fence. And it's not, and people think management intensive grazing, for example, is just animals moving in these small little groups, and they're moving very quickly into like, I don't know, every 6 hours or 2 hours, whatever they're thinking. No, it's not that at all. It's not intensive grazing. Goats always graze intensively. It's intensive management. It's a thinking person's way of approaching managing the forages with those animals. I've never seen a goat go with some clover and get up there and go look at it and step back going, I better wait on that one. It doesn't do that. They're going to go at it full blast, period. And it's our job as managers to use that to where we want them and how long we want them. And with all of that, underneath is the principles of forage growth and response. And we are adapting our grazing to match that, given the principles of good grass growth and good soil health. That's, again, another long-winded answer. But it's in my book, in all sorts of different perspectives of that, of both books. And I find it fascinating.
It is fascinating. And we have just barely scratched the surface. And I think I've asked you about 25 or 30% of the questions I was going to ask you, but it's getting a little long. And I wanted to give a shout out to Phil Hopkins, one of our podcast listeners and a Goats 365 member, who recommended you as a guest because he read your book and thought it was so fabulous and that you'd have so much to share. And so I asked him if he had any specific questions for you, which he does. And so he was wondering, because he's in Tennessee, and was wondering what kind of heat and drought resistant plants could survive their Tennessee summers.
Cactus, great. Don't anyone write that down.
Okay.
Tennessee's got warm, humid summers. And the question a little bit is addressed warm season grasses versus cool season grasses, that type of thing. And I had this conversation actually a little bit here I'm in Western Oregon, and someone was talking about a warm season grass. And she said that it was a warm season because it was really growing well in warm season. No, the concept of warm season, and we're talking warm season stuff versus cool season stuff. Warm season grasses and cool season grasses are not just because they grow at different times. They're actually very strictly identified by their biochemistry. Warm season grasses have a different biochemistry than cool season grasses. As you all know, all grasses have green leaves. What's in the green leaves? What do those green leaves do? Photosynthesis, right? And biochemically, what happens is water plus CO2, a carbon dioxide, together makes a carbohydrate. That's the big equation of photosynthesis. There's a lot of steps in there and all sorts of, it keeps scientists busy lifetimes. But the end result is water plus carbon dioxide equals a carbohydrate. The carbohydrate that comes out of that initial thing has 3 carbons in it. Then you take that 3 carbon, combine it with the same 3 carbon, and you get 6 carbons, which is glucose. And then all roads lead from glucose. That's biochemistry. And anyone who's ever taken a biochemistry course and handled their 12-pound textbook, that's the big thing. The first thing you learn is that glucose is the starting point of everything in terms of biochemistry. And it comes in a plant, it starts with this photosynthesis. And that first product of photosynthesis is a 3-carbon product, except warm season. Cool season grasses, that's the case. In a warm season grass, in addition to doing that, they have a separate photosynthesis setup that produces, you have CO2 and H2O, gives you a 4-carbon unit. It's got 4 carbons in it. And that uses that 4-carbon unit to turbocharge the rest of the photosynthesis during hot weather. So what it has done is that a warm season grass is designed biochemically to handle higher temperatures. And I will not bore you with the details of that. But the end result is a warm season grass, one of the first products of photosynthesis, has 4 carbons. Hence, it is known in the world as a C4 grass. And cool season grasses, their main first product is 3 carbons, so it's known as a C3 grass. And you'll see this in the literature all the time, C4 grasses versus C3 grasses. And species are different. Warm season grass has a C4 pathway. The cool season grasses do not. And it's that clear. Now, that doesn't mean that they can't grow, and some warm season grasses can get down into cool temperatures, and some cool season grasses can get up to hot temperatures. For example, a classic in Tennessee or in northern Alabama or in northern Georgia, Virginia, a classic cool season grass is tall fescue, and it will grow also in the edges of the very hot weather. It does okay, as long as it has something called endophyte in it. Endophyte's the fungus that grows there that gives it a very symbiotic, it allows the tall fescue to handle the hot weather and the bugs and the extra trampling and all that stuff that goes on. So the grasses are much more resilient to that. And that's the great K31 tall fescue had that. Unfortunately, endophyte, the classic endophyte, is also toxic to animals. So you get the issue of summer slump and all sorts of things, the problems. We've improved things. There's now endophyte that's animal friendly. It's called novel endophyte. So you can get tall fescue varieties that have novel endophyte in it that'll do just fine and will be perennial. Tall fescue is the one cool season grass that will do very well in those areas that have hot, long, humid summers. And it's known as the fescue belt because it naturally grows there. But if you're going to plant it, you don't want the classic endophyte. You want the novel endophyte. But they call it literally, it's called in the market novel endophyte. That's the type of endophyte that does not have the toxic alkaloids. So to answer his question, tall fescue would be a good one. Other types of a lot of legumes, a lot of clovers will work. There's also some, perennial peanut, things of that nature.
What about sorghum Sudan grass?
Okay, sorghum Sudan grass. It's a warm season grass. Warm season grasses are things like sorghum Sudan grass, sorghum or Sudan grass, corn, Johnson grass, teff. People call it teff grass, but it's teff. Crabgrass. And then a lot of the other, Bermuda grass. Those are all C4 warm season grasses. The thing was, some of them, like Bermuda grass, is a perennial. So that's an important thing. You grow perennials or annuals. But sorghum Sudan grass is an annual. It has to be planted after the frost, otherwise it'll die. It'll rot in the ground, and it'll grow. And the good thing, well, it's changed since the old ones. There are new traits to sorghum Sudan grass that are very, very good. But the thing that people are afraid of sorghum Sudan grass are 2 things: nitrates and cyanide. Nitrates that's a problem in a lot of different grasses occasionally. That in both of those problems we can control with good management. The nitrates you can test for, you eat it when it's higher. Usually that'll happen in very long cloudy weather where there's a lot of fertility, a nitrogen fertilizer. So the nitrogen gets absorbed into the plants, but doesn't get up to the leaves. So it's not converted into carbohydrates. So it kind of sits there as nitrates in the stems, the lower stems, and sometimes the leaves, especially if it's been overcast for a long time. And what happens is they can't have photosynthesis as well. So that happens. We just have to deal with that. Actually feed some grain. That will help. The other part though is the cyanide. And if you guess wrongly on the cyanide, the results, unfortunately, are spectacular. So you don't really want to do this wrong. The thing with sorghum Sudan grass is very simple. Don't ever graze it under 18 inches. There are varieties now, most of the varieties of sorghum Sudan grass are going to be low in cyanide. It's not cyanide per se, it's a compound that has the cyanide part of it. And then when it gets into the rumen, that cyanide part is released and then absorbed into the blood. And then bad news happens. Animals actually, including humans, have a way of detoxifying low levels of cyanide and get rid of it in the urine. But it's relatively easy to get above this threshold there, and you really don't want to. Cyanide is, of course, extremely toxic, and if an animal dies of cyanide poisoning, the blood is bright red because the blood can't get rid of the oxygen into the cells. That's why it's bright red, because the animal basically suffers from lack of oxygen very quickly. The thing is that basic rule is that compound is called Dhurrin, Dhurrin, is if that variety has high levels of it, it's going to be in the lower parts of the plant when the plant is still very young. So you wait till the plant's 18 inches high and then graze it from then on, or cut it from then on. But right after a drought period, so there's this new young growth underneath, that can be high in cyanide. So you have to be careful on that. And also after a frost, you have standing sorghum Sudan grass, and then a frost comes, don't graze it or do anything with it for about a week to 10 days. And then the cyanide will have volatilized off. But sorghum Sudan grass is an annual. It produces an incredible amount of feed quite safely if you know how to handle it. We know how to manage it. And it's got a couple of traits. The brachytic dwarfs now, which are smaller, send out more tillers, and they're very good for grazing. And so that's a trait. There's a trait that's called BMR, brown midrib. You turn the leaf underneath. The same happens in corn. So you turn it underneath, instead of being a green, you know how corn big leaf is, and underneath it is just kind of this big rib. It's normally green. Well, if it's brown, it's got that brown midrib trait, which effectively gives it a more digestible fiber. It's a mutant. It's been around for a while, and it's not a GMO. I mean, these things have been just in the classic way have been chosen. And I know people who plant sorghum Sudan grass. It's BMR, brown midrib. The TDN value, for those who know what TDN is up about 5 to 7 units over non-brown midrib. Not extra protein, but it's more energy. So it's the fiber is more digestible. So that's a good trait. And there's one called photoperiod sensitive that it's now out there. Just like 90-day corn or 120-day corn, sorghum Sudan grass will go to seed after a certain period of time, right? And once it goes to seed, it loses a lot of its nutrition. It's much lower in protein, much lower in energy. Well, the varieties that have this photoperiod sensitive trait, they don't have that fixed number of days. What they do is they get their signal to go to seed when the day length starts getting much shorter, which is sometime in late September or early October, which means that when they're growing, they stay leafy until that point. So you can get a much longer grazing period on those. So those are 3 traits that have become part of sorghum Sudan grass that have made sorghum Sudan grass incredibly better, a valuable tool under the right conditions. It is an annual, so you got to plant it every when it's not a perennial, but still we know how to manage it. It's got a couple of potential issues, but again, we know how to manage it, and it provides a lot of feed. So I hope that answers your reader's question.
Yeah,
Probably in
I'm
much more
sure.
detail than you wanted.
Yeah, oh, he'll love it. He's a nerdy science guy, and so he will love all of the details, I'm sure. And then the last question I was going to ask was one that was submitted by one of my Ghost 365 members, who I thought it was just a really nice general question. And that was, what sort of land would I be able to run my goats on and not worry about them dying? And my answer to that is just always like, well, the more browse, the better, because there's no worm larvae in the leaves.
That's right.
So browse is good, but I thought I know
Yeah.
you've got something way better to say than that.
No, actually, goats are browsers. I mean, they evolved as being browsers, and there's all sorts of good things that I mean, cattle and sheep, bison are grazers. What they do effectively is vacuum the ground. They go through there and have their heads down and they do things. Goats, of course, eat upwards. They browse. There's all sorts of evolutionary ramifications on that. Goats are much more susceptible to parasites, as you more than well know, and you've had all sorts of hours of talks about that. And of course, they have a different capability of handling wormers, and the dosages are different, and veterinarians are aware of that. And goats are goats. I mean, there's things that have to be done with goats that are different. They're not sheep under those conditions. From a nutritional point of view, that's a whole different thing. But from a veterinary point of view for parasites, oh my gosh, yes. On the other hand, goats can eat leaves, which we know. They don't get oak toxicity, whereas cattle and sheep do. And the reason are the hydrolyzable tannins that are in oak leaves. Tannins aren't tannins. There's condensed tannins, which we know about, for example, Serratia lespedeza, and they are able to naturally reduce the amount of parasites. But there's a different type of tannin called hydrolyzable tannins, which are toxic. And they will, besides getting gastritis, do permanent damage to the kidney, and animals die. And cattle and sheep, if they eat green acorns and oak leaves on the ground, that's if they have enough of it, it can be real bad news. But goats are okay with it. And the reason they are is they have a protein in their saliva that binds to these hydrolyzable tannins so that they can't cause the damage. They're not absorbed. Sheep and cattle do not have that, but goats and deer do, because they evolved to handle these things that are common in leaves of tall plants, whereas the grazer that's normally eat that, and when they do, they can get hit with this toxin, and there's been a lot of veterinary reports on lots of deaths that way. So in that sense, now come back to the original question: where can I put animals that have lots of browse? I mean, in order to run goats on pastures, in addition to the principles that I've been discussing, those principles I've been discussing apply to whatever grazers that are being used, or at least ruminants, all right? But goats being browsers could avoid a lot of the problems of parasite issues by simply reaching up. As you're absolutely right, that's what goats do. And there's other things that they can, they reach up, and there's a mountain lion up there. That's a problem. But in general, lots of browse. And to put the goats out on paddocks and using them for intensive grazing requires a lot of skill. And unfortunately, if that skill's not there, you end up losing goats. If they have browse, and that's a major part of it, it reduces that risk a lot. I don't know how better to answer, because it's why goats are not allowed in solar farms. They like to climb.
Yes, exactly. Yeah. We've talked to solar installers before, and they have said that, like, this is known in the solar industry. It's like they will put solar panels on a field with sheep, but not goats.
It's not rocket science.
Yeah.
We know that goats climb, and yeah, you can build solar panels so the goats can't climb, and that has to be built in. But I mean, sheep are perfect for that type of management. And again, there's a big effort going in that direction. But one thing that I would want to say, though, and it's kind of addresses one point you made earlier about mob grazing. It's a concept in grazing. You've heard of stocking rate. Well, stocking rate has an important point in range country. We have a certain number of animals, and they pay per animal unit that's out there per month. That's a standard thing. That's how that was developed over 100 years ago. And there'd be 5 sheep to a cow's animal unit, and 1,000-pound cow or 1,100-pound cow's animal unit, and there are 5 sheep equal that. I'm not sure how they deal with goats. It's probably the same. But the end result is that has certain purposes. From an intensive grazing, or in places where there's browse and there's all sorts of stuff, that term means nothing. There's a different term that does mean something. And the term I'm thinking of is stocking density, which equates to grazing pressure. And it's very, very easy to calculate. It's the number of pounds of animal per acre. So if you've got, 150-pound goats, and you've got 10 of them, which gives you 1,500 pounds, and there are in 1 acre, you've got a stocking density of 1,500 pounds. If you put a fence in the middle of that, so you get down there on half an acre, your stocking density is 3,000 pounds per acre. If you put a fence again in there again, halfway, now the goats in that little part, a quarter, is 6,000 pounds. So you see what I'm saying? Mm-hmm. So it's the number of pounds an animal per acre. And the higher that number, the more evenly the manure is spread, and you can use that number, and it's grazing pressure. So putting goats in an area to take out the weeds depends on the stocking density. If you put one goat out in 5 acres just to get rid of the weeds, 800 goats might do a better job, right? Well, how do you figure it? Well, you calculate the stocking density. And the higher the stocking density, the better they're going to get the weeds. And here's where you come in certain terminology. Most people are using stocking densities under 5,000 pounds, which would be 5,000 pound cows per acre. That's, and then they move on. You get to intensive grazing, good rotational management intensive grazing, you're getting up 60, 70,000, 100, 120,000 pounds an acre. Mob grazing is over 200,000 pounds an acre. Now you're moving them quickly. You have enough feed and you move them before they go. They don't scalp the ground. You move them. If you're doing mob grazing, you're probably moving them every 12 hours or a day. And you put it, but getting goats up to 30,000 pounds, I know from experience getting sheep, tall fescue, for example, is not a particularly palatable, compared to other grasses, tall fescue is always left. You always get these clumps of tall fescues because the animals eat everything else. Well, if I can get up to about 15 or 20,000 pounds an acre, they eat the tall fescue. And that's not hard. You just use electric fence. And you do the same with goats. So if I want to get rid of certain weeds, you get them tighter. You get up and the calculations you can do square feet, 56,400, whatever is square feet per acre, you can do the calculation. But if you can get up to 20, 30,000 pounds an acre with goats and then move them accordingly with the 5-day rule and all that, you take out weeds very nicely. And some weeds like gorse, which is like, Scotch broom, you know what Scotch broom is? It's good if you don't. It's a yellow flower bush. And gorse is the yellow flower bush that has 2 3-inch thorns on it. Goats can handle that, at least a part of it, when on the edges. Depends again on stocking density. But there's all sorts of weeds that will come out when we can be taken out when you get the stocking density high enough. And you can do that calculation before you, if you don't have enough goats, or you go, okay, I can get the stocking density real high by moving the fence in so they're really more tightly grazing. The stocking density is a way of expressing grazing pressure, and that's what that means. So that goats can be managed, but always keeping in mind the issues with parasites. So I think that might at least address the question that you might have had, whichever that question was.
Yes, about what kind of land you would have to be able to run your goats on and not worry about them dying. And yeah, you definitely covered that in there. This whole episode has just been fantastic. You've provided everyone with so much valuable information that's so actionable. I think people are going to understand all of these concepts way better since you explain them to us so clearly and in such a measurable way, not just kind of like, well, you have to play it by ear, trial and error. Like you've got some really solid numbers and stuff and ways that people can do the math. So I'm sure I still have a million questions, but I know we've talked for a while. I'm sure our listeners have more questions. Where can people find you online?
Well, I'm not really doing much answering because I'm trying to retire. So I'm not spending time doing things. We get my books for starters, and I've got 3 books out, and they're on Amazon and they're on other places as well. Premier has got them, and it's very easy to get them. And Amazon charges whatever they charge, as you know. But there's a lot of material in those in a lot of the detail that I've talked about, but it gives a lot of that stuff right off the top. And the books have indexes, so it's real easy to find stuff. And they're also in Kindle, so you can do it that way as well. So there's that. I do have a website, woodylane.com, and there is a contact me type of thing in that. So there is a Facebook, Woody Lane Nutritionist, you'll get something there as well. But I frankly don't spend a whole lot of time answering emails. To answer something when you're a professional takes a lot more long time, because once it's written and it's in digital form, it can be spread across the world. So you really want to I do. And also as a consultant, one of the things I've learned over the time is that each farm is unique. So an answer to you with your farm may be very different than an answer to your neighbor for the same question. And I don't really feel comfortable giving a lot of answers I mean, we could always talk principles. I have lots and lots of information about Sorghum Sudan grass or something of that nature. But the knowing a person's farm, you need to walk across it. I need to listen what they're saying and see things. And I'll see things differently than a farmer will, because I'll be looking for different things. And I'm listening to what they are saying and also what they're not saying. And that gives me a chance to dovetail and fashion options and advice that fits their situation. And to my mind, that's really the best and only professional way I can really work with farms, is to really understand where they're coming from, what they're trying to do. And like, what should I plant sounds like a simple question. But in reality, it's an incredibly difficult one, particularly if you're dealing with perennials, because if you're dealing with perennials, you're going to live with that for a long time. One tip, though, I could say, if you don't know what you're going to do, and as we say in square dance calling, if you don't know where you're going, go there quickly. But what you could do, if you want to learn how to learn some of these principles, is get annual ryegrass. Annual ryegrass is usually the cheapest seed. You could broadcast it on the ground. First, you have to get the ground so it's pretty bare or cut down a lot. And you broadcast it, put 50 pounds an acre. That's one bag of seed per acre. Just broadcast it, put some fertilizer on it or whatever you want to, and then step back and watch it grow. And I've done this on my own place, and annual ryegrass is the secret of the world, because you can get that. It's usually the cheapest seed. Get pure stuff. Don't get it as a mixture. You want annual ryegrass. You broadcast it out there, maybe 45, 50 pounds an acre. It's like one bag an acre. And then get some fertility and water on it, and it's going to explode. And what it does is it gives you extremely high quality forage, a lot of it, which gives you a chance to move fence around, learn how to do this stuff, apply the principles, et cetera, et cetera. And then after a year, it goes away. And you haven't made an investment. You have to live with the mistakes. It gives you more time to make, now I'm thinking about this. I've learned this. I can ask next year, I might do it again. Give me another year. And, it gives you an opportunity to learn as well as plan for the future years. And we've used this a lot as a initial year becoming used to good grazing, and doesn't have the ramifications of you're stuck with it for 10 years that you've planned and you haven't put a lot of money, you haven't broken ground. So that's important, breaking ground relative to soil health. We never did get into that part, but the end result is that having 2 acres of annual ryegrass that's growing at high speed, you learn how to graze with good techniques, and that's it.
Yeah. We've done that. I bought the ryegrass because it was cheap and I had some bare spots, and it grows beautifully. It's this lovely fine grass that the goats just love, and it was wonderful. And I really loved it.
Well, we're talking annual ryegrass, and that's a little different. Yeah.
Yeah, it was
Anyone who's come through
annual.
my courses knows that there's annual and perennial, and they always feel guilty if they don't say because annual is a different species
Yeah,
and
and
it has
it's
different
cheap.
characteristics.
The annual is cheaper.
Yes, it
That's why I
is.
bought it, because it was cheaper. I'm like, well, I know it's only annual, but it's cheaper. So for
Oh,
all the reasons you said, like, I'm not really sure what I'm doing, so this is
and if
a
someone
cheap
doesn't know,
experiment.
get a bag of it, put it out on in the backyard or something, and just do that and just see what happens. And then if it doesn't grow, then there's something else going on weird. And so you haven't wasted any money there. But if you do it and you go, wow, then you take a pasture, and actually that's going to be what you're going to do for a year on that pasture and
Yeah.
see what happens.
Well,
So,
I love what you said about needing, basically you said what I say all the time when people ask me questions, is the answer is it depends. There is no one size fits all answer for anything related to living beings, whether that's humans or goats or whatever. And the example I always give is that if my neighbor of 20 years, 4 miles away from me, had supplemented her goats with copper the way I had to, she would have killed them all with copper toxicity, because we had completely different water, even though she was 4 miles away. My water was what a former intern referred to as fart water because it stank so badly.
a lot of sulfur in it.
Yes, it was very stinky stuff. So thank you so much for joining us today.
Well, Deborah, thank you for inviting me. It's been a pleasure. You you appreciate the types of stuff that I've been talking about and writing about. And people can find out in the books that I have. I do things like I relate growing forages, for example, to the witch trials in Salem.
Wow, that's a good teaser.
Well, yeah, considering the issue of no-till planting. And it's in my second book, book two. I didn't just bring it up because of history, but because it actually has ramifications of what we're doing today. I don't mean the trials, but I mean yeah, what caused them.
All right.
So
Well, thank you. Well, on
thank you
that,
for asking.
yeah, on that note, we'll end. And now I really want to go read your second book.
There's the witch trials, and also I worked John Lennon into it, and some other things that are rather, they all have to do with forages. Trust me.
Awesome. Thank you.